Hey everybody, in this video we are going to be reviewing Module 1 in preparation for the midterm exam here that's coming up soon. So in this video I'll be covering Module 1 material, and then I will be creating 2 additional videos for Module 2 and Module 3 respectively, so that you can navigate each one easily and find what you need to review quickly. Before I start with Module 1, just going to kind of go over a few materials that are helpful to have with you. So this review page is stapled into your packet that you already have, and you can also find this attachment in the announcements in our course. You'll also find in your packet the formula chart that you'll be getting during the midterm exam. It looks like this. It's about 4 pages long. It's got some formulas on there, some equations, as well as these tables. These tables are part of Module 3, so we'll look at the formula chart in each of the different videos based on what is necessary and pertinent to know. So the overview of the exam, or the outline, is 30 multiple choice questions, and because we are covering 3 modules in those 30 multiple choice questions, there's going to be 10 questions roughly from each module covering the material. So that's what your midterm exam looks like in terms of its format. The review here, however, is all open-ended, and so that's just to help you prepare and know exactly what answers there are to each concept. You'll also find in the review packet towards the back, you've got the answer key, so you can also check here for the answers as you go through it. In the review, I'll be walking through step by step each question though. So for Module 1 right here in the packet, it's questions 1 through 15. And so what I'll be doing in this review is I'll be flipping back and forth between the notes that we've already taken earlier at the beginning of your packet, and then we'll flip back here and connect it with the question that we're working on. So let's get started here with number 1. Number 1 says that we have a situation where we're collecting information on different topics, such as people's favorite restaurant. And we're being asked what type of data and what level of data that would be. So we got data type and level. And we are collecting people's favorite restaurant. So they get asked a question and they respond with the name of the restaurant. That's their favorite one. So that's a type of data, even though it's not numeric. Data doesn't have to be numeric all the time. And so looking back at your notes from Module 1, in box A, we talked about the 2 types of data, qualitative and quantitative, and then the 4 levels: nominal, ordinal, interval, and ratio. So for the type of restaurant, since they're responding with a name, then let's first address what type it is. And since the type has to either be one of these 2, quantitative or qualitative. Quantitative would be a value, qualitative is a descriptor. So the name of the restaurant is a descriptor, so that's qualitative, and I'll just put ... there because it's a long word, but qual rather than quant. Qualitative is the name of the restaurant. Then we have what level. There's 4 levels. The 4 levels increase in complexity, starting with nominal being the most basic, going all the way down to ratio. And so a restaurant, since it's a category or a name, it's going to be nominal data in the form of names, labels, categories. So pretty straightforward there. It is nominal for similar reasons as the type as well. And then there's a second question here: what graphical summaries would be best to portray this type of data? And in the notes, we also talked about the different representations. So for example, with nominal data, I put the 1. So anything with the 1 or 2 in the notes is a bar graph or a pie graph. Those are things that could be helpful for nominal or ordinal data, for example. So just put graph, pie chart, or a bar chart. And so there you go. There are the three things: data type, level of measurement, and then where it says graphical summary, there's the third item. Now, this question asks various concepts. On the midterm exam, you'd have a question that would say, what's the data type of this thing? It only asks for one of these. This review question covers all three concepts, but on the midterm, you'd probably only get one of these to answer in the question since it's multiple choice. So it'd say, if you're collecting information on so-and-so, what level of measurement is it? And then your answer choices would be different options for the levels, or the types would be the different answer choices it was asking for the data type, etc. So number 1 is very similar to number 2. So I'm going to leave you to try number 2 on your own just to test your knowledge on that. It's the same type of question, except you are being asked about patients' ages as they enter an ER. So answer number 2 later on, and then you can check your answer with the answer key towards the back. And I will also be posting the entire solution key as well as a PDF in the announcements later on. So you can check number 2 there later. Same thing for 3 and 4. 3 and 4 are also similar to number 1. So you can try those out as well. Where in number 3, you're being asked about a satisfaction survey, and they're answering on a scale from 1 to 5. Number 4 is asking about temperature, and so you can answer accordingly for number 4 as well. And again, you can check your key later on once I post it. Let's look at number 5 now. Number 5 says, what is the main difference between a parameter and a statistic? So these are vocab type questions. And as I mentioned earlier, at the very top, your exam breakdown looks something like this: 30 multiple choice questions. So since there's 30 questions, some of the questions are vocab questions, and some of the questions are like calculation-based questions. So for example, Module 1 was very vocab heavy, a lot of vocabulary. So those types of multiple choice questions are going to be the ones where you want to have the definitions memorized of certain words. And there's other questions in modules 2 and 3 that were more calculation and numbers based, so you'd have to know how to calculate something in those. But anyways, number 5 is one of those examples where you have to know some definitions. And same thing with 1 through 4 as well, very definition based and knowledge based. So what's the difference between parameter and statistic? In the module 1 notes, I gave you this diagram in box D in module 1. And here's the definitions of sample, population, statistic, and parameter that go along with this review question. But here is the diagram that I gave you. Looks something like this, where you have a big group, which is the population, small group, which is the sample, and the big group, anything that calculates out of the big group is called a parameter. Any number that you calculate from a population is a parameter, and any number that you calculate from the sample group is called a statistic. And it's pretty convenient that the two words that start with the same letter go along with each other. Population goes with parameter, sample goes with statistic. So a really helpful thing to remember during the exam. So what's the main difference between a parameter and a statistic? It's exactly that. Parameter goes with population, and a statistic goes with the sample. And so looking at the actual definitions towards the back for number 5, I'm not going to write it out because it's already written right here for number 5. A parameter is a numerical description of a population. Right, so there you go. Population goes with parameter. And then similarly, but just slightly different, statistic goes with sample. Right, so there's what you want to know for number 5. Looking at number 6 now. Do the following symbols represent a statistic or a parameter? So this was actually in your Module 2 notes page, but it kind of overlaps between the both. But looking at your Module 2 notes, we had this box right here that we filled out in Section B that had various symbols and terms and what term goes with which symbol. So certain ones go with population values and certain ones go with statistical values. Um, so there, it gives you 4 symbols right here. There should be, I'm not sure if it printed on your packet or not, but on mine it didn't, but there should be a bar on top of the X. That's a particular symbol. And so we'll list out each of these, right? X bar, mu, standard deviation, and S. These are the 4 different symbols right here. So starting with X bar, that is the sample mean. I know it only asks which one goes with the statistic or which one goes with the parameter. So talking about what it goes along with has to do with whether it goes with the sample or a population. So for example, X bar goes with the sample and it's a mean. So that would be calculated to be a statistic. And then mu is the population mean. So that has to be a parameter. And this goes along with number 5. Why do those go together? Sample and statistic are correlated or are together paired. Population and parameter are paired. And the best way to remember that is what letter does it start with? That's not why they're together, but that's a way to remember that they are together. They're just words, though, that pair with each other. Then these two down here, they're different numbers that you can also calculate. The first one is a Greek letter sigma. That's the population standard deviation. And then again, population calculates out to be a parameter. So just like the population mean is a parameter, the population standard deviation is also a parameter. They're both numbers that you calculated from the population. They tell you different things, but they both came from the population, and that's why they are both parameters. And then the last one, S, that's the sample standard deviation, and that obviously then now is a sample. Oh, not a sample, statistic. Yep. And so sample value calculated is categorized as a statistic. There's number 6. Number 7, describe the difference between each of these types of samples. Okay, the sample is, like I mentioned in the module 2 notes, it's a group, a smaller group within the bigger group. But there's different ways you can pick that small group depending on what the situation is. And the definitions for those sampling techniques, the way you pick that small group, are these 5. There are more, but this for the purpose of this class, at number 7, the definitions, you can either find them in your notes or here they are again in number 7 in the answer key. But each of these has a specific definition that you'll want to memorize. Stratified sample is dividing the population into a bunch of groups and then picking people from each group. That's called stratified sampling. Cluster sampling is breaking the population into particular clusters or groups and picking one of those clusters. And so the most common way to think about this one is geographically. For example, in the example in the notes, I chose to cluster the data by our campus, Dallas campus, right? That's a geographical group. Whereas you might have another group in Phoenix or another group wherever. But I did cluster sampling in this example here to pick the Dallas campus because that's the geographical cluster, how to group people into that particular group. There's other ways to cluster sample as well, but that's just the one obvious one. Sample of convenience, that means you pick members that are readily available. So this one is really common in healthcare, especially because um, some some studies and research and clinical trials will be interested in doing research on a particular kind of condition. But you have to find patients who have that condition and they are also wanting to be available for that. They would have to voluntarily choose to be part of that clinical trial. That's a sample of convenience. Whoever is readily available and wants to participate would be part of that. So that's how you collect that sample because um, it's a smaller group within the bigger group of patients that have that condition. We can't test everybody with that condition, but we can test a sample, which is anybody who's wanting or readily available to participate. So that's a sample of convenience, which is really common. We have a couple other ones. Systematic sample. Systematic sample is when you arrange everybody in an order. Think of a single file line. Everybody's in a single file line. So um, think of it like this. I'm just gonna put some marks here. You got, let's just say we use the number 10, right? And we give every patient a number. There's patient number 1, 2, 3, 4, 5, so on and so forth. Every patient gets their own individual number. And so what systematic sampling is you line up your patients metaphorically, you put them in order, give each patient a number, a unique one, and every kth element is selected to be part of the sample. This is not a typo. Kth is just representing any number, like every fifth patient or every third patient. So for example, this kth, if it's the every third patient, then we would select the third, the sixth, and the ninth patient to be part of our sample. Or if it's every second patient, every other patient, 2, 4, 6, 8, and 10. That's a systematic sample where you pick every kth patient, every certain order patient. Then you have a simple random sample. A simple random sample is exactly what it sounds like. It's very simple. You just pick everybody in the sample at random. So think of everybody in a bag, randomly scrambled up, and you are metaphorically drawing names randomly from that. And so everybody has an equal chance of being drawn. So it really depends on the situation. But a simple random sample is everybody's in the same group together in that sample, and we pick at random. So there's some explanation and background behind number 7. So you can kind of write down some notes within number 5 and number 7 accordingly based on what I said. Let's keep going. Number 8 talks about histograms and the shape of the distributions. We talked about symmetric and skewed distributions. And when you have histograms, depending on the data set, the bars might stack in a certain pattern or shape. So for example, on part A right here, if you roughly trace, I guess, in a smooth way, the corners of your rectangles, just like that, and we look approximately where is the peak of the histogram or the distribution, it should have a particular shape, whether it be symmetric or skewed. This one looks like it's symmetric because the peak is in the middle, going from left to right. So when the peak is in the middle, that's what we call symmetric. That's a symmetric distribution. Then we have other types of shapes where if I just roughly connect the corners of my rectangles, now this one looks like the peak is not in the middle of the number line anymore. It looks like the peak is kind of pushed towards the left. So really important to study this a little bit more closely. You want to look at where the tail is. Our eyes naturally go to the tallest rectangle or the tallest part of the graph, but that's misleading for the name of this type of a skew. When it's skewed, the tallest part of the graph will be pushed to the one of the sides, you want to look at where the tail is. That's going to tell you whether it's skew left or skew right. The tail is on the right. So this is an example of a right, or sometimes it's called positive skew, right or positive skew. And then if it's reversed the other way, you notice that the flat part starts here and then it goes up towards the end. In that case, the tail is where we want to look, which is on the left side. So there's the tail on the left. So this is a left or negative skew. There's the different types of skews. Number 9 through 11 ask about the mean, median, and the mode, and how those are ordered in different types of skews, whether it be positive, negative, or symmetric. So in each of those, skew right, skew left, or symmetric, the order of the mean, median, and mode is in a specific order. Although we're covering module 1, I talked about this in the module 2 notes. This kind of overlaps between the two, but it falls under module 1 because it still talks about the mean, median, and mode, but in context of the type of shape that we have in the distribution. So here's what you should have had in your notes, or this is what we talked about during class for that type of a problem where it's asking about, so for example, in a skew right data set, what's the relationship between the mean and the median? For example, there, when it's skew right, you look closely, the mode, median, and mean go in this order from left to right. That means the mode is the smallest number because it's closest to the left of this number line. The more left you are on the number line, the lower your value is, and the higher you go, the bigger your value gets. So the mode and the mean are going in this order. Mode is smaller and the mean is then bigger than that. And then the median is in between there. So this one actually just asks about the mean and the median. So we would say for a right skew right or positively skewed, the median comes first and then the mean. It would look something like this. So this is a right skew, just like that. The mean would be right there, and the median would be right there. So the relationship between them is that the median is less than the mean. The median is less than the mean. And the reason why we say less than is because we're not looking at the height of the graph. We're looking at left to right, which one shows up first and which one shows up second. Right here, the median shows up first, meaning it's less than the mean. The mean is a little bit further past on the number line. So you can think of this beginning as 0 and then over here as 100, for example. The median is closer to 0, the mean is closer to the 100, so the median is less than the mean. Right, and that matches what we have right here in this picture as well from the module 2 notes. So you can also then answer for numbers 10 and 11 for those respective diagrams. Number 12 and 13 talk about using the midpoint formula. And it will give you two numbers. Really straightforward question on the midterm that you'll see is how to determine the midpoint. And if you look on your formula chart in your packet, this is the same formula chart you'll get during the exam. You don't have to memorize this formula, but it's right here. Upper limit plus lower limit divided by 2. Again, you don't need to memorize this because you'll have it available during the midterm, but you do need to know how to use it. Upper plus lower divided by 2 when it asks for what is the midpoint of this class. It's asking what's the midpoint between these two numbers. The class starts at 30 and ends at 38. What's the midpoint? So all we would do is 30 plus 38 divided by 2. Right, so that's 68 divided by 2, and then the midpoint would then be 34. So I did that mentally, but if you needed a calculator, um, you can use any scientific calculator to practice. On the midterm, you'll get a calculator built into the Canvas platform. It looks similar to this one right here that you see on my screen. I'm using the Desmos calculator. It's similar to the one that'll be available and the buttons that'll be available during the midterm exam in Canvas. But you could also just Google scientific calculator. And you could even just use the one that's available on Google, or you can click on another one that says scientific calculator. They're all going to have more or less the same functionality that will be the one in Canvas. But it's good to practice with that and be able to make calculations using that calculator. 13 you can try on your own. It's very similar to number 12, just using the midpoint formula. Then we have 14 and 15 right here. These ones ask you to interpret a histogram. And they're asking about proportions of data. And what that means is how much of the data falls at or above or below a certain value on the number line. So for number 14 here, using this histogram, it says what proportion of the data falls at or above 28. So here's 28. At or above would be anything to the right of that. And so that would be these two rectangles, because that's everything at or above 28. So those rectangles are, so for part A, we've got 7 plus 2, which is 9. We would add these two rectangles up. 7 plus 2 is 9. And since it's a proportion, we need to figure out what's the total, 9 out of how many. So we'd also need to collect and count how many are these rectangles in total with all of the data as well. Right, so 6 plus 2 plus 2 plus 2, that's 6 plus 6, which is 12. Right, so there's a total of 12 so far. 12 and then plus 7 is 19, and plus 2 more is 21. So there's a total of 21 if you collect all the rectangles together. So that's taking the heights of each rectangle and adding them all up. Right, so 9 over 21, that's your proportion. And on the midterm, you may not see that as an answer choice, because if you can simplify the fraction, you should. So notice how both these can be divided by 3 to get the 3 over 7. So you would probably see 3 over 7 as your answer choice there. Part B asks about any data that falls below 21. Let me use a different color for B. So part B, 21 is right here. Anything below the 21. So that would be all 3 of these added up. So that's 6 out of, and the total again is 21. Remember, a proportion is out of the total of all the heights of the rectangle. So 6 divided by the total, which was 21, the same one from part A. So 6 out of 21. Again, we can simplify this to become 2 out of 7. Right, and then you can do something similar for number 15 here. For the ones that I didn't cover in the packet, I went over a similar example so far in Module 1. So as you're working through your review, you can double check your answers with the answer key, and I'll also be posting a full solution key as well to each of the questions, including the ones that I didn't talk about. So you'll find that key in the announcements that where this video is also attached, so you can work along with that as well. So that brings us to the end of Module 1. In the next video, we're going to be reviewing the questions for Module 2. So I'll pause right here, and then we'll pick back up in the next video.